All right, so in this video, we're going to factor polynomials, again, specifically quadratic trinomials here, using grouping method, okay? In the previous couple videos, we factored using guess and check, and again, I suggest using that as much as possible. But if you need a method, if you need a process, then this is probably the way to go for you, okay? So let's go over some steps here. As always, the first thing you want to do, if possible, is factor out a GCF. Okay, any polynomial you look at that can be factored, you always want to look for a greatest common factor. All right. Once that's done, then steps 2 through 5 here are really the process. We're going to multiply a times c. So remember, a is the coefficient of the x squared term, and c is the constant. We're going to multiply those two together. All right. Whatever that product is, we're going to find two factors of that. We're going to find two factors of the product a times c that combine or add to give us the b value, okay? So remember, b is the coefficient of x. In this case, that's 5, all right? Once we've done that, we're going to split the middle term, okay, again, which is this 5x, into two terms based on these values, okay, or these factors we got in step 3. Once that's done, we can factor by grouping, okay? The great thing about this method is that it works for any quadratic trinomial that can be factored, okay? So, step 1, is there a GCF? In this case, there's not. X squared, 5x, and 6 don't have anything in common, so we're going to move on to step 2. So, a times c. So remember, a is 1, c is 6. So we're going to multiply those two together. So that product, a, 1, times c, 6, is equal to 6, okay? So let's think about the factors that give us 6 and which of those factors combine to be 5, okay? So 1 times 6, okay? 1 times 6 is 6, but when I combine those, I get 7, so that doesn't work, all right? 3 and 2, on the other hand, combines to give me that b value, okay, or that coefficient of b, which is 5, all right? So what we want to do now, we're going to go into step 4 here. We're going to split the middle term into two terms based on these values, okay? So we're going to break 5x into 2x, okay? The 2 comes from here, plus 3x, okay? So 2x plus 3x is going to give me 5x, all right? And then we're going to factor by grouping, all right? So I'm going to take x squared plus 5x plus 6. I'm going to rewrite this 5x as x squared plus 2x plus 3x plus 6, okay? So now I've got a polynomial with 4 terms, and when we went over factoring by grouping, we usually had a 4-term polynomial to do that, all right? So we're going to group these first 2 terms together, and we're going to group these last 2 terms together, and we're going to factor each binomial, okay? So this has an x in common, okay? And when I take that out, I'm left with x plus 2. These are divisible by 3. When I take that 3 out, I'm also left with x plus 2. And remember, when we factor by grouping, we need this binomial to match up, all right? So I want to take this x and this positive 3. That's going to be my first binomial, okay? And then the binomial that matches up is going to be my second binomial. So this is the factorization of x squared plus 5x plus 6, all right? So that's going to be my answer. So if we did guess and check, we would have gotten the same thing. As always, when you factor, use the distributive property, multiply these back out together, and you should get what you started with. So you know you're correct. All right. So let's look at number 2. If you want to pause the video here, as always, go ahead and pause it, give it a try, and then come back and check your work. Okay. Step 1, GCF. In this case, all 3 of these values are divisible by 3. So we want to factor that out. And when I take a 3 out, I'm left with x squared, okay? Negative 33x divided by 3 is minus 11x. 72 divided by 3 is 24, okay? So now this is what I want to factor using the grouping method. The 3, it's going to be part of my answer the rest of the way down, but I'm going to use grouping to factor this trinomial, all right? So a is 1, b is negative 11, and c is 24, all right? Think about standard form. So step 2, a times c is positive 24. Okay. Step 3, I want to look at the factors for 24 that are going to combine or add to give me b. All right, so because, remember, think back to guess and check. If this sign was negative, then I needed my factors, my constants here to be negative. So I'm looking for negative factors of 24 in this case. So I'm going to start with -1 and -24. Well, they combine to be -25. All right, so that doesn't work. So let's try -2 and -12. Okay, well, those combine to be -14. That doesn't work. And let's go to the next one. -3 and -8. Okay, -3 and -8 does combine to be -11. So that's going to be the pair of factors that matches for me. All right. So step 4, as always, we're going to rewrite that -11x using these two values. So -3x and a -8x. All right. And then we're going to factor by grouping. Okay, so let's go back to what we started with here. I'm going to rewrite that -11x as -3x and -8x. Okay. And then I'm going to group these together. So notice I use brackets here. It could be parentheses, could be brackets. I kind of like using brackets, especially in situations like this. All right, so I'm going to group these two terms together, and I'm going to group these two terms together. And remember from before, I'm always going to separate that by a plus sign for now. Okay, so GCF of this binomial, GCF of this binomial. So the 3 doesn't go away. I'm going to take an x out of this, and I'm left with x minus 3. When I look at this binomial, the best thing to take out is a -8, because I need that x minus 3 to match up. And that's what's going to happen when I take out a -8 here. All right? So the 3 again doesn't go away. Remember, I'm going to group that x with this -8. That's going to be my first binomial. So 3 times x minus 8. And then the binomial that matches up, x minus 3, is going to come out next, okay? So this is the complete factorization for my binomial, or excuse me, my trinomial that I started with, okay? As always, multiply these out using the distributive property, and you should get what we started with, okay? So that's factoring quadratic trinomials using the grouping method.